y can be modeled by this function, where x represents the number in hundreds of skateboards sold. So this one's just shown to you because the main range of polynomials people just think, oh, if it's a degree 1 or degree 2 or degree 5, it's always x ER, y ER. And but I said, but sometimes not for word problems, right? So we can think about this. In the context, sometimes your domain range isn't just what the function has. So what's the degree of this function? The largest exponent is 4. So this is the degree 4. They don't have to be listed from high to low exponent, right? So like degree 1, this is the first one. That's not how it works. Okay? What are the leading coefficients and the constant? The leading coefficients, the value in front of your largest exponent, so it's 1.25. Is your leading coefficient. What's the constant? Yeah. Negative 3,200 for that. I look like I have worse considered right hand, right? My daughter right now is phenomenal. That's terrible. Okay. So x represents the number in hundreds of skateboards sold. So if you get x equals 3, that would be 300. If you got x equals 7, that would be 700. If you got x equals 70, that would be 70 plus 2 zeros, which is 7,000. It's in hundreds of skateboards sold. So you're just going to add 0, 0 to the end. And they do that so that you don't have to make a ginormous window, right? So if you had 700 skateboards, your window from 0 to 10 would work, right? Because your answer would be 7. 700 instead of having to make the window so huge. So that's how they do that. And P is the profit in dollars. Your constant is always your y-intercept, right? So that yesterday, your constant is your y-intercept, so it's where it crosses the y-axis. So what the heck is negative 3,200 in this context? It's the profit, right? It's your y. The profit is negative 3,200. What does that mean? Exactly. So your y-intercept is when x equals 0, correct? And x in this case is number of skateboards. So if you sell those skateboards, they're basically in the whole $3,200. Okay? So if you look at the end behavior of this graph, and you punch into your calculator, punch that into your calculator. So 1,000x plus 1.25x squared minus 3,200. And remember, when we punch into a calculator, we get 1,000x plus 1.25x to the 4. You don't want to put in x to the 4, you can go x, this little symbol, which is below the clear button, 4. That's x to the 4. And then minus 3,200. Not negative 3,200, you say minus 3,200. Now remember, our window, let's think about this. Profit can be negative and positive, yes? Profit can be negative and positive. So we know that our window, our y minimum is going to be at least negative 3,200, so we can see the y-axis where it's profit. So we make our y minimum negative 3,200. I'm going to make my y maximum 3,200 just to see if I can see what it is. Y scale is just what each of those ticks are. So if you leave it at 1, it'll still draw it, but it's just going to be a solid black line because you're going to have 3,200 ticks. 15 tiny ticks from 0 to 3,200, and 3,200 15 tiny ticks from 0 to negative 3,200, right? So if you make them maybe be 500, each tick be 500, you might actually see some ticks along the y-axis. If you leave them at 1, it's not going to show you. Now, my x minimum, what should I make it be? X is the number of skateboards. Can you sell negative skateboards? What's the minimum number of skateboards we can sell? Minimum number of skateboards you can sell. None. You can sell none. That's your minimum. So your x min should be 0. It shouldn't be negative. You shouldn't even see the negative window because you can't sell negative skateboards. And then x max, I'm going to make be 20. got to be 2,000 skateboards, right? 2000, 100 skateboards. And I'm going to make the X scale be 1, you can still see it. I'm going to be 2. So right now I have my X minimum at 0, my X maximum at 20, so that's 2,000 skateboards. My X scale at 2, my Y minimum at negative 3,200, my Y maximum at 3,200, and my Y scale at 500. That's graph UAB. Make your Y max be 10,000. You have 10,000 on profit. You can make it be 100,000, and you'll see you're just seeing part of an export graph. People will say, well, you told me an export graph makes a W if it's positive, right? Well, you're only seeing partial parts of that export graph because we cut it off at x0, right? And our x being 0, so you only see partial parts of it. Describe the end behavior. It ends positively on the right. And we knew it was going to do that anyway, because it's a positive leading coefficient. When I have a positive leading coefficient, I end positively on the right. When I have a negative leading coefficient, I end negatively on the right. It doesn't matter if it's 3, 1, 2, 3, 4 million. It's always going to end that way on the right. This makes sense because the more skateboards you sell, your profit should increase, right? What are the restrictions on the domain? 0 to infinity, you write it like that, or it can be in set notation, which is x is greater than or equal to 0 x. Either of these are fine, just depends on how they have the answer on your diploma. How do we find x-intercept? Well, we plug 0 into a y and we could solve. You guys don't actually know how to solve that, so we can't do that today because we can't factor x4 at this point. But how can you find it on your calculator? Well, x-intercepts are when y equals 0. So you can either put y equals 0 into your y sheet and find out where they intersect, or you can do second trace 0, second trace number 2, which is 0, and then it wants you on the left bound and the right bound. So the graph looks something like this. Well, you're not actually seeing it, but the graph looks something like this. Then it says left bound, right bound to find the x-intercept. This is on the left of the x-intercept. It's part of the graph on the right. And we need to do that. So second trace number 2, and then you need to on the left side of the 0. Enter, and then on the right side of it. Below the x-intercept. I got 3.0 on the blinker one. 3.0, 3.08. So what does that mean? Think about it. On my x-axis, my y is what? On the my y is 0. So at this, I repeat it, right? That makes no money. What is this? 3 skateboards? That's 308 skateboards. Catch here, is 308 skateboards, would that actually get me 0? 308 skateboards would make me a little bit less, right? You actually need 309 skateboards to get you to round it. 309. See where you break even. Or you could say profit $0, right? What's the profit of the sale of 1,200 skateboards? This is where people go wrong. So skateboards is X, right? So some people will tell me, okay, I need to find out when X equals 1,200. Yeah? No. That would be 12,000. So that'd be 120,000 skateboards, actually, if you plug this in correct. And how do you represent 1,200 skateboards? Skateboards are in the hundreds, right? So we're actually going to look for when X equals 12, because that's 1,200 skateboards, right? It's in the hundreds. And you can just plug it into your calculator. So you want to find P of 12. And we just plug in correct. 1,000 times 12 plus 1.25, 12 to the 4, minus 3,200. Or if you make your window large enough, your y-max large enough, so I made my, if you make the y-max here at 50,000, when you know an x value, how can you plug it into your calculator to find a y? You can go second, trace, value, and x equals pops up. And you can put in 12. So to do this on your calculator, you go second, trace, number 1 value. So when you know x, you can press these buttons. And then x equals pops up, and you're going to put a 12 in and press enter. And it will give you 34,720. Or you can physically do the math, and it will give you 34,720. Both will give you the same answer. If it errors you when you punch this into your calculator, because your y-max isn't big enough for it to find it, right? Your y-max is only 10,000, and your answer is 34,720. But you don't actually have to know the calculator stuff. You can literally just do the math, right? And you're the same answer. This question, on the axis given, get the polynomial function with the given characteristics. Okay, it's degree 3. Degree 3 means that we're looking sideways x. I know that much, right? So I know I'm going to, this just means I have something either like this, or something like this. That's what degree 3 means. What does positive leading coefficient mean? Positive leading coefficient. This is your end behavior on the right arm. If there's a positive leading coefficient, you end positively on the right. If there's a negative leading coefficient, you end negatively on the right. Doesn't matter what degree, that's how it works. So positive leading coefficient means I end up on the right. And 2x-intercept means 2x-intercept. 2 times touching the x-axis. Touching and going through. Degree 3 can have at max how many x-intercepts? Degree 3. At max it can have 3 x-intercepts. Degree 2 at max can have 2 x-intercepts. Degree 4 at max can have 4 x-intercepts. Degree 5 at maximum can have 5 x-intercepts, right? So this degree 3 has at max 3 x-intercepts, but they're not asking us for 3, right? If it has 3 x-intercepts, we would just go through it 3 times. Whenever it has a maximum, you just have to go through every single time you go up and down, right? This one only has 2. So how can I make it only have 2? I'm still ending up on the right on this one. It's a degree 3, but the only thing that this graph is not covering is 2 x-intercepts. This one actually has 3. What could I do to this graph to change it so that I have 2 x-intercepts? Could I take this bump and move it down to just touch the x-axis? Could I take this bump and move it down? So I could just Come up. That's the x-axis. Come back down, and then look. Then I still am ending up positively on the right, which covers the positive leading coefficient. So it makes that weird S shape, so it's degree 3. And this way only has 2 x-intercepts instead of 3. So just pick that bump when I construct it. Another way I could have done it is I could have went like this. I could have went right through with this one. Yeah? But then when I come down, I can't go through. If I go through, I'm going to get 3. And go down and bounce back up. That would also get me in here. Okay? So at some point, you're going to have to go, this is called tangent. At some point, you're going to have to get a tangent bump. But you only get 2. Okay? Let's look over. You guys try this one. See. I would use pencil if I were you. Try it. The next 2. See if you could possibly come up with a way. Just try it out and use pencil. Okay, polynomial function degree 4. So it's either going to be some weird W or some weird N. And this is a W as well. I know some people don't like, but that is just basic W. So let me know. Negative leading coefficient means we're going to end negative or down on the right. Always on the right. 4 x-intercept means every single time I'm changing direction, I'm going through the x-axis, right? Because that maximum I can only have 4, so I have the maximum number of x-intercepts. So also with degree 4 or degree 2, my arrows are always going the same direction, right? Even graphs, arrows to the right. So I'm going to end down on the right. So I'm going to start down here. I'm just starting on the right. Now, I'm going to go through. Yours looks relatively like that. It could look like this. Go through. And just go a little bit through. That's through. Way up here and down here. Doesn't matter. 1, 2, 3, 4. And negative. Your graph could look very much different than mine, right? You have to go through 4, and you have to start down, end up. So degree 4 means like arms in the same direction. Positive coefficient means up on right. 2 x-intercept means I'm going to touch tangent twice. Because what I'm technically going to have to do is just bounce and bounce. So, up on the right. Down. And you somehow make myself a W that only touches twice. I don't know where I can do that. Make the bottom of the W touch, right? One. Trace the following polynomial functions. Determine the function is odd or even. If the arrows are going in opposite directions, it's odd. Even degree is both up or both down. How do you determine whether the leading coefficient is positive or negative? I don't know how, well, if I took away the equation and blocked the equation, how can I tell this graph is a positive or negative? Right. So look at the right arm. Positive, right, on, up. Negative, right, arm down. Number of x-intercepts. Look. How many times it touches the x-axis? In domain and range. Domain and range are super easy if it's an odd function, it's xer, yer. If it's an even function, it's going to be xer and then y is greater than if it's a minimum, and less than if it's a max. Less than or equal to, greater than or equal to, less than. So let's look at this one. Your quadrants, if you don't know this, go 1, 2, 3, 4. That's your quadrant. So this graph extends from quadrant 2 to quadrant 4. Arrows in opposite directions. So is this function odd or even? Mackenzie, odd or even? Odd. I look at my right arm. I'm ignoring the fact that I have the equation up here because I want to see if I can do this without my equation. The right arm is down. So this is a positive or negative leading coefficient. Down on the right, negative. Proving it's true, odd degree, degree 3, negative leading coefficient. There are how many x-intercepts? It crosses 1 and touches 1. There's 2 x-intercepts. The domain of this graph, all polynomials unless 2 or prime are xer. So the domain is xer in set notation or an interval notation, negative infinity, positive infinity, maybe the whole number line. The range, my arrows are one arrow is going up and one arrow is going down. So I'm going all the way to positive infinity and all the way to negative infinity. So line here. Flip over. You try the next two. Answer all the same questions. A, B, C, D is no. Or both. You fill it in just like these ones. I'll leave this up here so you have it for that. Okay, let's go from quadrant 2 to 1. What degree is it? Even or odd? Both arrows in the same direction, so even. Okay, that is what you should get. Sure. Negative or positive leading coefficient? Positive leading coefficient. And positive on the right. I think x-intercept is next. How many? 2 x-intercept. Domain and range. The domain is xer. The set notation or interval notation. Negative infinity, positive infinity. And my range is the minimum. So the lowest value my y can be on both these is -5 or higher. So y is greater than or equal to -5 for yer. If it's greater than -5 for interval notation, it starts at -5, it's equal to, so it's a square bracket, and it goes to positive infinity. This one's quadrant 3, quadrant 1. It's an odd degree. Specifically, let's take degree 5. The arrows in an opposite directions, right? Positive leading coefficient ends up on the right. X-intercept 1, 2, 3, 4, 5. This looks like it actually goes through, so I'm going to say 5. I tested it every more. No. 5 x-intercept. So this is 5 x-intercept going to have to at least be degree 5, right? Domain is XER, range is YER. Our function just shows are unless to work on it. But the error's going lots of drugs. As an aside, what's the constant of this equation? What's the constant of this one up here? What's another word for constant? Whenever you read constant, what should you think? Yes. So when you see constant for polynomials, you should think y-intercept. When you see leading coefficient, you should think how it ends on the right-hand side. Okay? You're not going to say, oh, by constant I mean y-intercept. They're never going to tell you that, but that's what it means. So the constant is whenever we without a variable. So this question would be -4. For this one, it would be, I don't know, 5. That's my guess. Okay? Now flip over. For each function, use the degree and the sign of the leading coefficient to describe the end behavior of its graph. Take the possible number of x-intercepts and the value of the y-intercept. So the degree of this is, instead of 5, the degree is 5 with a blank leading coefficient, positive or negative? Positive, it's positive 4. Degree 5 is going to look like one of those weird ones, or like this. Whoa, that was wrong. Positive leading coefficient means it's actually going to be like this. Right? The graph extends then from quadrant, it should be 3 to 1. Yeah? What is the maximum number of x-intercepts for this equation? What would it be? 5. So your degree, the degree of a function, equals the maximum number of x-intercepts. And that should be a little notice at that. Now you won't always have that many, but that's the maximum you could have. And what's the y-intercept for this equation? Positive 2. Is that the constant? And the constant is y-intercept. Now why does that work? Whenever you hear y-intercept, you should always think x equals 0. When you hear x-intercept, you should think y equals 0. If I put 0 for all my x's here, all of these are going to go away, and I'm just going to have to plus 2. That's why the y-intercept is plus 2. Because if I put 0, 0, 0, 0, those will go. Okay? So, the degree of this is degree 4. With a negative leading coefficient. So it's degree 4 negative leading coefficient. So that means it starts down on the right. And it ends down on the left. Yep. Oh, I didn't see that. This is a 5. It's really hard to see the numbers on this wonderful board. This is what the notes look like. Look how clear they are. And then I put them to smart notebook. And that's what I think. Fantastic. So, this is a 5 here? Yeah. Is it a negative? Yeah. So this is degree 5, negative coefficient is LPA. So if it's negative, it ends negatively, just like before, because it's degree 5, it ends positively on the left. It's going to extend from 2 to 4 by doing my maximum number of x-intercepts 5 again. And my y-intercept, what's my constant on this one? I don't have a constant, which I don't. All of them are variables, what my constant be? Some people will say +1. If I had a +1 at the back, wouldn't it be there? If I had a +1, it would say +1. It doesn't. So what do I put at the back and it doesn't get anything? That's 0. The only thing I can add to something that doesn't change it completely if I can add a 0 to it. So my y-intercept is 0. We're literally going to have 5 minutes. Work on that bad boy, and then we're moving on. All right. So there's 3 ways you can find the remainder. So we're only going to look at remainder theorem for today. Synthetic division and long division. Long division, we're going to look at one example. So we're just going to go over it. But we're mainly going to use synthetic division to do more first. We want more things than just the remainder. However, if we just want the remainder, we can use remainder theorem, which up here states when a polynomial p of x is divided by a binomial x minus a, so the remainder is p of a. So you just take this binomial and work it out to be what x equals, and plug it in, you'll get the remainder. The other thing here is, if the remainder is 0, then this binomial, x minus a, is a factor. That's huge. So that means every polynomial you can break down into factors, right? So when we did quadratics, you would factor it into 2, like most polynomials break down into factors. When you factor a quadratic, you get your 2 factors, right? Well, we can say that if we plug the binomial in and we get a remainder of 0, then it is a factor. So whenever you read is a factor, that is them telling you the remainder is 0. So whenever you see is a factor, that is fancy pants words for remainder is 0. Everyone forgets it. That's why I'm writing it here. Remember I told you you're going to pull the horizontal stretch out or your horizontal translation figure wrong? Is a factor will be on your text and it will be on your diploma. And whenever you see is a factor, you need to know to I just underline it and write a little arrow off that says remainder is 0. Because that's how they tell you the remainder is 0 without saying remainder is 0. Now why wouldn't they just say remainder is 0? I don't know. They don't. They say is a factor and you need to know that the remainder is 0. Okay? So determine the remainder of this polynomial if it's divided by x plus 1. We don't use the factor, we use the root. So we just go x plus 1 equals 0. Move our 1 over, so x equals -1. And that's the value we plug in. We don't plug in the factor, we plug in the answer, the root. So we're not going to do long division synthetic today, we're just going to do remainder here. Remainder theorem states that I have x minus a. If I plug in a, so if I want x minus a equals 0, I get x equals a. If I plug in a, I get my remainder. That's what remainder theorem states. Okay, so we're going to do that. We're going to plug in -1. So p of -1. P of -1 is -1 cubed. Whenever he has a new geometry, means the x is out of x, right? So -1 cubed plus 4 times -1 squared plus -1 minus 6. So we get -1. -1 squared is +1. So 4 times +1 is +4. Minus 1 minus 6. And we get negative 1 plus 4 minus 1 minus 6 is negative 4. So my remainder is negative 4. If you don't believe me, watch the long division that I'm going to do. Do not freak out if you do not know how to do the long division that I'm going to do. I've never seen a question on long division is used in the curriculum, but we show it to you just so you understand. Remember when you did long division way back in the day? Whenever ASCII has the bottom, you bring up and you write remainders 3 or whatever was left over. Same thing here. So we're going to watch. We're dividing by x plus 1. Like I said, I'm not going to make you do long division, so you can pay attention or you can write it up too. And we're dividing it into x cubed plus 4x squared plus x minus 6. If I didn't have a plus x, I'd have to fill in as plus 0x. I'd have to still write it, okay? I have two numbers. I look at two numbers. Just like when you would have like 700 divided by 10, you have 10. You have to look at the first two numbers, 7, and see how many times it's divided into x, right? So we have x plus 1, and we're dividing into x cubed plus 4x. What do I multiply x by making x cubed? X squared. So I'm going to put an x squared here. Then I go x squared times x is x cubed. X squared times 1 is positive x squared. Subtract them. X cubed minus x cubed. Cancel. 4x squared minus x squared is 3x squared. Bring down my number. Plus x. And I say x times what is 3x squared? 3x. I put up here. Plus 3x. And then I say 3x plus x. So 3x times x is 3x squared. 3x times 1 is a positive 3x. Then I subtract them. 3x squared minus 3x squared. Cancel. X minus 3x is negative 2x. Drop the minus 6. What times x is negative 2x? Negative 2. 2 times negative x, negative 2x. Negative 2 times 1, negative 2. Subtract them. Negative 2x minus 2x cancels. Negative 6 minus the minus 2, negative 4. What's the remainder? Negative 4. Exact same answer. That was horrendous. Perfect answer. Proving I'm correct. So someone came up with remainder theorem realizing that if I just take the root of my factor and I plug it in for all the x's, I get my remainder. If I ask you anything else, like I ask you to factor it, or ask you to give me all the x-intercepts, you have to do long division exercise so that you get more information. But if the only question I have is what is the remainder, you can just plug it in and give me the answer. If I ask any more information, you're going to have to do more work, which is the next two lessons. But if I just ask for the remainder, you take your x, your root, so in this case x equals negative 1, plug it in and get your remainder. Okay? All right. That should at least make you feel better that this is metaphorical and not more work. All right. We have x cubed plus x squared minus x plus 3 is divided by x minus 1. What's the remainder? So I'm not going to use x minus 1. I'm going to go x minus 1 equals 0, x equals 1. And I plug that in. So I'm going to find p of 1, which just means I plug 1 in for all the x's. So 1 cubed plus 1 squared minus 1 plus 3 equals 1 cubed is 1, 1 squared is 1 minus 1 plus 3. And then you get 1 plus 1 is 2, minus 1 is 1, plus 3 is 4. So that's my remainder, 4. Or you can do long division. Up to you. Option. That one is restricted to one way. You can do long division. Go ahead. Try number 3. Now some people will say x plus 2, and then I go x plus 2 equals 0, x equals negative 2. They're like, well, why do you do that step? It's just easy. Because what if I'm dividing by instead divided by 2x plus 1? You're not going to use minus 1. You're going to get with 1 over 2x equals negative 1 divide by 2, x equals negative a half. So you actually fill negative a half in for all x's, if this was your factor. Just a side note, as to why we're doing that step. I know it looks ridiculous, x plus 2, we use minus 2. But if it's 2x plus 1, we have to solve for x. So we're talking p of negative 2. And it's going to be 2 times negative 2 cubed times 4 times negative 2 squared plus 3 times negative 2 times 6. 2 times negative 2 cubed is negative 8. Minus 4 times negative 2 squared is positive 4. Remember when you put these in, if you're putting them into calculator, make sure you put them in brackets, because the negative 2 squared on brackets tells you negative 4 is not true. 2 times negative 2 is minus 6. Is minus 6. You get negative 16 minus 16 minus 6 minus 6 is negative 44. So within my long division, I would get remainder negative 44. That's left over when I factor it.